It could be a bundle branch block. It could also be, for instance, let's say you have ventricular dilation. So let's say you have eccentric hypertrophy due to volume overload. By the way, what heart sound is that? We've already covered it. That's going to be an S3 heart sound due to a volume problem, but that's going to stretch out our QRS. On the other hand, what if the QRS is tall? Not what still would be wide, but what if it's really tall? That's going to be indicative of hypertrophy more so than dilation. So a wide QRS is more indicative of ventricular dilation. So let's say dilated cardiomyopathy, but a tall QRS is more indicative of hypertrophy. We're going to cover hypertrophy in greater detail today. Okay. Now, let's say obviously, if we're talking about the ST segment, we're going to look for elevation versus depression in the ST segment. So just by what I'm saying is just by knowing normal, we can quickly figure out abnormal. However, if you don't really understand normal well, you're not going to find a lot of these things. Remember, you don't find what you're not looking for in the EKG. What if the T wave, for instance, this is a normal T wave, but for instance, what if this T wave is wider? Well, we know that the T wave means ventricular repolarization. If it's wider, that means it's taken more time for ventricular repolarization to occur. But if the ventricle doesn't repolarize, it can't reset to be able to start the next heartbeat. So everything is going to stretch out. Okay? If this, what happens if this T wave, for instance, is peaked?